Hello and welcome to this session in which we discuss the important reactions of aldehydes and ketones. The first one, of course, you can pause it, solve it mentally, and then you can verify the answers. The first one is a very important reaction. This is called aldol condensation, and it happens when a compound has a alpha hydrogen, which means adjacent to C double bond O, we have a acidic hydrogen. There is a carbon which contains a hydrogen. So two molecules are involved. So if we have two molecules of this, so the first molecule will be acting like a nucleophile. It is going to form a nucleophile. So it will be CH2 with a minus. And if you can think of a second molecule also, because it's a condensation reaction, so it involves two molecules. So this would be attacking it over here and forming an addition compound. So we get a aldol. What is aldol? Aldol is beta hydroxy aldehyde and ketone. This is beta hydroxy aldehyde and ketone. Now this is highly unstable. If you heat it, you will get a double bond formation over here. So this is aldol, and then we have the aldol condensed product, which is this. This was question number one. Second is an example of a Cannizzaro reaction. Now when we talk about say Cannizzaro reaction, how it is different from aldol, it occurs when the compound does not have alpha hydrogen. So in this case of a benzene with 2 CH involved, then the adjacent carbon does not have the scope for having a additional hydrogen. So in that case, it's a disproportionation reaction. Ideally, the two molecules would have involved, but because the single substrate has 2 CHO, so we can show the reaction intramolecularly. So in this, one of the aldehyde is oxidized, it is oxidized, and the second is reduced. So you can see it's a disproportionation reaction. Next, in presence of manganese oxide, two molecules, so two molecules of the acid undergo decarboxylation and dehydrogenation. So you can imagine that CO2 leaving and this H2 also leaving. So what essentially is left behind is uh, this molecule, which is the preparation of the ketone. So it's a ketone preparation. Next, this is Grignard reagent plus and minus, and this is plus and minus. So the first step is addition. So if you add it, so this will be OMGBr, and this is H over here, and this is H. Then we can, when we hydrolyze, we can see that the metal non-metal bond is something which will hydrolyze first, and we eventually get what? The alcohol CH3 CH2OH. Remember, if you use formaldehyde, we get 1 degree alcohol. With higher aldehyde, we get secondary alcohol. With ketones, on similar lines, we get a tertiary alcohol. Next is uh, Stephens aldehyde synthesis. Next is Stephens aldehyde synthesis. In this, we use SnCl to HCl. It forms the addition compound. First, H2 adds over here, and then it hydrolyzes. It's an important way of getting the aldehyde. So it is CH3CHO. Next is an important reaction. This is benzine condensation. Benzine condensation, in which two molecules add and form a compound which is called benzene. Benzene is different from aldol, that is, aldol was beta hydroxy, this is alpha hydroxy. If this is a functional group, this becomes the alpha carbon. Next, if you identify this agent, this is a Tollens reagent, and aldehyde does show the Tollens test, which means the substrate is oxidized, is getting oxidized, and Ag plus ion becomes Ag, silver particles, which deposit on the bottom of the container in the form of a silver mirror. So it is also called the silver mirror test. Then next is the Itard reaction. The Itard's reaction. So it is an important way of preparing the aldehyde. So we have, this will be CHO, benzaldehyde preparation. Next is, this is the Perkin reaction. Perkin reaction, in which aromatic aldehyde and ketone reacts with anhydride of a acid in presence of its sodium salt. Now clearly what we can see over here, that first nucleophile is going to form, it is going to add over here. We have a similar aldol type reaction. So if we say C6H5 representing benzene, this is COH, this is H, then we have CH2, C double bond O, O, COCH3. On further condensation under application of high temperature, two things happens. This bond will break. right, and form an acid over here, OH and H over here, and this will undergo dehydration. This will undergo dehydration. So what essentially we get is this molecule CH double bond CH COOH. This is called cinnamic acid. This is cinnamic acid contained in oil of cinnamon. So these were the important reactions from the JEE mains and the NEET perspective for the chapter aldehyde and ketones. Thanks for watching this video. Best of luck.